Hello and welcome. In this video, we're going to talk about ordinary differential equations. So what are differential equations? Differential equations are equations that contain at least one differential coefficient. For example, if we have this equation x dy dx minus y squared equals to 0. This is a differential equation. It contains the differential coefficient dy dx. So as long as it contains at least one differential coefficient, it is considered as a differential equation. Two major categories of differential equations are ordinary differential equations and partial differential equations. In partial differential equations, we deal with partial derivatives, and it is another topic on its own. So we're just going to be talking about ordinary differential equations. So moving on, I'm going to be referring to ordinary differential equations as ODEs. Now, as it has been defined already, right, our differential equations must contain at least one differential coefficient. So we can have our differential equations containing more than one differential coefficient. For example, I can have my ODE to look like this: d squared y dx squared plus 2 dy dx plus 10y equals to sine 2x. This is my ordinary differential equation. Now, we have something called order, right? Order. Now, our differential equations can be categorized into first order, second order, third order, and so on. So how can we tell which equation is first order, which equation is second order, which equation is third order? Now, before we proceed, if you haven't subscribed to this channel, do well to subscribe. Hit the notification bell to get notified when new videos are uploaded. Now, moving on, what is the order of a differential equation? The order of a differential equation is simply the highest derivative in the equation. So taking a look at this equation, the highest derivative is a first derivative, dy dx. So this is a first order differential equation. This is a first order ODE, right? Now, when we take a look at this equation, the highest derivative is a second derivative, d squared y dx squared. So this is a second order ODE. And it goes on and on like that. If I have d cubed y dx cubed as my highest derivative, it becomes the third order, and on and on and on. Now let's move on to solution, solving an ordinary differential equation. Now there are many ways to solve ordinary differential equations, but when we have a first order ODE, these are the four methods, the four major methods that can be used to solve first order ODEs, right? But in this video, we're going to just talk about direct integration and separation of variables. In next videos, we're going to go into homogeneous equations and linear equations. So without wasting much time, let's go into direct integration. So what determines the method you use to solve is how your equation looks like. Now, when you have your equation looking like dy dx equals to f of x, you know this is a first order differential equation because it has what? A differential coefficient dy dx. You can easily integrate both sides, right, to get what? Y equal to integral f of x. Very simple. If we have, for example, dy dx equals to 3x squared minus 6x plus 5. This is a first order differential equation. To solve this ODE and simply get the value of y, I can just easily integrate both sides. right? When I integrate dy dx, I have y, and that's going to be equal to integral 3x squared minus 6x plus 5 dx, right? Dx is a function of x. Alright, so we already know integration, I believe. Alright, so to integrate this, we add 1 to the power and divide by the new power. So this becomes 3x to the power 2 plus 1 divided by 2 plus 1 minus 6x to the power 1 plus 1 divided by 1 plus 1 plus 5x plus c. So this becomes 3x cubed over 3 minus 6x squared over 2 plus 5x plus c, and then it becomes x cubed minus 3x squared plus 5x plus c. Very, very simple. This is the simplest form you can have for your ODE. Now, what if we have a question that looks like this? X dy dx equals to 5x cubed plus 4. Alright? When you take a look at this, you can easily rearrange to have it in the form dy dx equals f of x. Alright, so I can divide both sides by x. I'm going to have dy dx equals to 5x cubed over x plus 4 over x. Right? So dy dx equals 5x squared plus 4 over x. And then I'm going to integrate both sides and have y to be equal to 5x cubed over 3 plus 4 ln x plus c. Whenever you integrate 1 over x, you have what? Ln x. And that's how I got this. So this is our answer. Very, very simple. If you need to revise integration, it will really help you to understand ODEs. So do well to revise integration. Now moving on to the method of separation of variables. Whenever your ODE is in the form of, say, dy dx equals to f of x comma y, it has a function of x and y. For example, dy dx equals 2x over y plus 1. This is a function of x and y. What do? We use the method of separation of variables. So what does it mean to separate variables? What we want to do is to have the function of y staying with the y and the function of x staying with the x. So we can cross multiply to have y plus 1 dy equals 2x dx. Alright, so what do we do at this point? We can integrate both sides. So you integrate this side with respect to y. We have a function, integral of a function with respect to y, and we have the integral of another function with respect to x. So we have successfully separated the variable y from the variable x. Okay, so integrating this now gives us y squared over 2 plus y is equal to 2x squared over 2 plus c. Alright, and eventually we have y squared over 2 plus y equal to x squared plus c. Very, very simple. Now, what if we have something like this? Cos squared x dy dx equals y plus 3. We can rearrange, right, to have the y dx to be equal to y plus 3 divided by cos squared x. Now, taking a look at this, we cannot use direct integration because we have a function of x and a function of y. But we can easily use separation of variables, given that we have these formats right here, right? So we have cos squared x, where we have y plus 3. So what's the best way to separate the variables? We can divide both sides by y plus 3, right, or multiply both sides by 1 over y plus 3. So we have 1 over y plus 3. So y plus 3 cancels out y plus 3. Okay, now we have 1 over y plus 3 dy dx to be equal to 1 over cos squared x. Okay, we can easily bring dx to this side to have 1 over y plus 3 dy to be equal to 1 over cos squared x dx. And we have successfully separated the variables. Okay, I'm going to leave this to you to solve as your take-home assignment. So solve it and let me know your answer in the comment section. If you learned something from this video, like this video, share this video to your classmates and leave a comment if you have any question, and solve this question and drop your answer in the comment section. Thank you very much for watching. Goodbye.